everyone for attending this event. I'm delighted to be here at the launch of the Italian Reproducibility Network symposium series like this. The work that networks like yours are doing are so important for advancing culture change toward greater transparency and rigor and reproducibility in research. So I'm delighted to contribute a bit to that, and hopefully in my remarks we'll see the complementary roles that all of our communities play in trying to shift the research culture toward what we idealize science to be. The basic research interest that I have in my substantive work is on the gap between values and practices. What we want to do, what we're trying to do, what we think we should do versus what we actually do in our everyday behavior. And why is it that we often end up doing things that are different than our intentions? Both because of the limitations of our own minds to enact our intentions in our behavior, and because of the cultural constraints that we confront that shape and drive our behavior, perhaps in ways that are different than what we idealize or what we want from our everyday behavior. The Center for Open Science is really a practical application of that research interest in trying to understand the gap between scientific values and scientific practices, and how might we close that gap so that we can operate and be in a scientific community that reinforces and lives up to its values. So the slides I'm presenting, you'll see there's a link there. I'll also put up a link at the end if you'd like to retrieve and use these. But I want to begin with a reflection on what are scientific values? What are the things that we idealize science to be? And there are many ways that we could characterize that. The one that I often like to start with is Robert Merton's norms of science that he articulated in the 1940s and 50s, and trying to reflect on what makes science a unique activity and learning and knowing things about the world compared to others. And he identified 4 key norms. The first being communality, open sharing of information. You don't trust a claim that I make about my findings because I say, this is what I found. Trust me, that's what I found. We gain trust and credibility in claims by me showing you, here's the methodology that I used, here are the data that I produced, here's the process that I drew inferences from that data. And these are the conclusions that I arrived at, so that you can examine the basis of evidence and decide whether those claims are credible, right? Versus the counter norm of secrecy. Just trust me, that's what I found. Second norm is universalism. Research is evaluated based on its own merit, right? It's the methodology, the data, the inference process itself that determines the credibility of the findings, rather than, oh, that person's famous, they must know what they're talking about, so we'll trust that they found something true about the world. Another norm is disinterestedness. Researchers are motivated by knowledge and discovery, just trying to figure out how the things work, versus the counter norm of self-interestedness, right? It's a competitive environment. Really, my goal is to get all of the publications and all of the citations and all of the awards and all of the best jobs in competition with my peers. And then his fourth norm is organized skepticism. A researcher considers all new evidence, even against their prior work, to get a better understanding of how things work, versus organized dogmatism. I get my findings in my dissertation, and then I spend the rest of my career defending them against all of the people who are attacking my findings. And then while Merton didn't talk about it, a common norm that's raised in process is the norm of quality versus the norm of quantity, just producing as much output as possible. Now, you might recognize these as ways that people have talked about, think about, articulate what science can be, but an obvious question is, do scientists themselves endorse these norms, or do they endorse the counter norms for how they think science should be? Anderson and her colleagues did a study with about 3,300 NIH awardees, so US participants in this case, and asked them, which do you endorse as the way science should be, the norm or the counter norm that I showed on the previous slide? And what you're seeing in the gray bar is the proportion of the respondents that said they endorse the norms over the counter norms on average, 90% or more. In black, Very few people said, no, I think science should operate based on the counter norms, self-interestedness, dogmatism, right, secrecy over the norms. And then in the gray bars are people that say both of these are about equivalent, right? I think both of them should be used in how science should work. So then Anderson and colleagues said, okay, that's fine. Don't tell me what you think it should be like. Tell me how you behave in your research. And it looks like this. So still most people say that they behave according to the norms of science over the counter norms. But you can see in the gray hatches that many people are saying, yeah, and those counter norms also have influence on my behavior, more so than what I think it should be. And then Anderson and colleagues said, okay, that's fine. Don't tell me what you do. Tell me what all those other people in your field, what do they do? And it looks like this. We perceive that the culture, everyone else, is behaving according to the counter norms, that those are the drivers of scientific behavior. While even though we all comprise that same culture individually, we individually endorse the norms. So that gap between the top here, where almost everyone is endorsing the norms of science, and the bottom, most people are perceiving that the culture does not embrace those norms, is an operational definition of a dysfunctional culture. The values that we have are not perceived to be manifest in the way that the culture operates. And so one of the things that the reproducibility networks and the rest of the communities that are trying to improve research practices can strive for is, how do we align the bottom with the top? That the values that we have, that we bring to science, that's why we want to be here in the first place, are the things that we see, perceive, and are reinforced by in how the culture operates. So there are many things that people will identify as what are cultural problems in science that are getting in the way of us living according to our values, and those values presumably helping us to do more rigorous, reproducible science, accelerating knowledge and discovery. For us, it boils down to a key challenge that is at the core of this, which is the incentives for my success are focused on me getting it published, not on me getting it right. And we know that publication is the currency of advancement, right? You publish as much as you can in the most prestigious outlets possible, and that is a way to enhance one's career. And we also know that not everything gets published. Some things are more publishable than others, right? I'm more likely to get published producing a novel result, something new about the world, rather than replicating something that someone else has done or claimed to try to improve understanding or confidence in it. I'm more likely to get published with a positive result, finding a relationship between these variables, or finding that this intervention has an impact on the outcome, rather than a null result. Nope, this didn't occur. There's nothing here. And I'm more likely to get published if my findings all fit together. They're neat and tidy and reinforcing of whatever conclusion that I'm trying to draw, rather than messy with exceptions, things that don't quite fit. So a novel, positive, tidy story is the best kind of story in science, meaning that it's both the most publishable and it's actually the greatest thing, right? If you discover something new, can account for it completely, and your explanation is reinforced by all the data, that's an amazing contribution to science. But as we know, that doesn't happen very often in reality, right? The research we're doing is messy. It has lots of false starts. It has things that we think are going to happen, but then we can't quite fit this together. And so the understanding for the phenomena that we study emerges slowly, incrementally over time, with lots of false starts, lots of negative results, lots of things that don't fit the ideal. Those ideals happen over a long period of time, accumulation of many lines of research. But the reward system is very incremental. On every paper needs to have these characteristics if you want to maximize your career outcomes. So what that sets up is this challenge. Because certain kinds of results are more publishable than others, then I have a strong incentive to get the certain kind of results. And I have lots of opportunity and discretion in what I will do in my everyday behavior that might produce more publishable results at the cost of their credibility. And so there are a few different behaviors that can result from this incentive reward system that end up having dysfunctional qualities on why it is the culture doesn't necessarily align with how we think it should operate. So for example, I do many experiments in the lab. I might only report a subset of them in the paper, right? So the subset, how do I decide which subset get reported? Well, the things that fit together that make a nicer story are more likely to get in there. And while I'm not trying to mislead you as the reader, I will easily rationalize to myself why those experiments that didn't work, that were no results, they weren't really testing the phenomenon that I thought it should be. Or I'll just sort of recognize, that's not as publishable. Or even the editor says, we don't want that stuff. Remove that experiment. Just publish the ones that look nice. Right. Second factor is that there are many ways I might analyze my data as I'm trying to make an understanding. Some of those ways I analyze it might look better for publication than others. And of course, if I'm analyzing the data many different times, I might be engaging in overfitting, or what can be called p-hacking, without really realizing that I am leveraging chance to increase publishability while simultaneously seeking or following paths that are not as credible for the findings themselves. But in the rough and tumble of just trying to understand the research, where I am reasoning and trying to discover, I may be employing a lot of these biases that I don't even realize I'm employing, like hindsight bias. Oh, of course I would have predicted this all along. This is exactly what I thought was going to happen. Or confirmation bias. Oh, that finding doesn't align with my expectations. Let me try it a different way. But if the finding aligns with my expectations, I'm not going to try it a different way. See, came out how I thought it would. Without any reward for me sharing my methodology or my data or other things, why would I share it? The reward is about the publication. And so I don't need to be transparent and show you my work if it's not relevant in the reward system. And then the last one is replications. For me to replicate my own work in the reward system is a risk, right? If I find something interesting that I think will be publishable given how the reward system works, the reason to replicate would be to increase confidence, but the risk of replication is that my finding will go away. And then I will have lost this great thing that I have just found. And so that is a disincentive to conduct replications of my own work. And then if we reward novelty and innovation as the primary means of advancement, then why would you bother spending time trying to replicate my work? Because you're not going to get very rewarded for it. And so that's not worth your time either. And so all of these behaviors can have negative consequences on the credibility of the published literature, an exaggeration of what we think is true based on what the literature is because of what gets filtered out along the way. And we don't end up having these self-corrective processes. You can't really understand what it is I did because you don't have access to the full methodology, just my report of it. You don't know all of the other things I might have tried. You don't have access to the data to reanalyze to see if it's robust. And we're not having verification processes like conducting replications of particularly important findings. And all of that then leads to waste, slower progress than we could have, and friction in the process. We are discovering things, but perhaps if we shift the culture, we can accelerate that discovery and be more confident in the findings more quickly than we are now. So that is the challenge as we try to understand it in the work that we do. And what I want to focus on for the remainder of time is giving some examples, just a couple of examples of ways that we might intervene and shift the research culture, and then some evidence that that's occurring. And we could talk about many different examples. I just want to give some highlights of how we can think about this. We focus on three primary behaviors as the key things to change for improving the research culture. There are many other things to consider. So this is not the exhaustive set. This is just a core set that we think can make a lot of progress. First is sharing data. If you can access the data behind the findings that I produce, then you can test reproducibility. Do you get the same answer that I do? Did I make a mistake along the way? You can evaluate robustness. Is the finding that I have sensitive to the exact analysis decisions I made? Or is it pretty resilient? Even if you make different reasonable exclusions or otherwise, you still get the same type of result. And then open data allows aggregation and reuse for other purposes, which is just an overall efficiency gain. Open materials, if you can access my methodology, my protocols, the things that made the research possible, it's easier for you to evaluate what I did and how it is I did it, what conclusions I drew. And you might read my paper and say, boy, you left out what I see as the most critical part of your experimental design. I think you might not realize there's a confound there. Or, oh, no, that's an incredible insight that you had. You don't realize that you had a credible insight there. And that's really what's critical in your methodology. And then it's easier to build on, reuse, and extend methodologies if they're open. And then the last is pre-registration. And pre-registration has two key purposes in this context. The first is, if I did those 30 experiments and only reported 3 in the paper, it should be possible for you to see that there were 27 others and evaluate whether it was reasonable for those to be left out of the paper. Pre-registration of studies ensures that it's discoverable that work was done, whether or not it ends up in the publication pipeline, which addresses one of the key challenges of publication bias, right? The systematic ignoring of negative results over positive results. And then the second purpose of pre-registration is to help clarify the difference between what was planned in advance and what happened during the process or after the fact, unplanned parts of the research. Both planned and unplanned things happen all the time, and they're both very important because planned research is usually associated with hypothesis testing, right? We have some idea we want to evaluate, and we're directing this methodology to test that particular question, right? Confirmatory research is another term. And unplanned research is really important because it's associated with hypothesis generating processes, right? We get our data and then we start to dig into it. We're surprised by how different it was than our planned expectations. And so we explore the data and gain new insights of what might be possible. But a challenge for credibility is that we can often mix up exploration as if it was confirmatory hypothesis testing, and thus end up overconfident in findings that might be data contingent. This, we leverage chance in discovering them rather than subjecting them to true tests where we have a plan in advance and then determine whether the data support or reject that, rather than explore the data in order to find a way to support it. So those are the 3 key behaviors that we focus on, and happy to talk more about those. But I want to give one concrete example of trying to shift the incentives in the way in which the system operates, and then talk more generally and then open for discussion. And this is the model of registered reports. And if you're not familiar with this, I'll give a very brief version. What you see here is the cartoon of how science proceeds, right? You design a study, you collect and analyze the data, you write a report, and then you publish it. But of course, it's not that easy. There is this big barrier of peer review after you've written the report before you get to publish it. And in the standard model, peer review is the barrier to overcome in order to get the reward that you need, the publication. And the barrier is best overcome depending on the results that are in the report, right? How novel, positive, and tidy are they? So that the reviewers will say, wow, this really advanced knowledge, this opened new doors, whatever it is that made this an important contribution based on the outcomes. Now, the challenge in this context, as we've already discussed, is that all of the incentives for me as the author are make that report as beautiful as possible in terms of the results in order to get through peer review. And that can introduce all of those challenges in the prior slide. So the key change with registered reports from the standard model is to move peer review, the first stage of peer review, to after the design phase. So if you submit a registered report to a journal, what you submit is the introduction, right? Here's my research question. Here's why this is an important question. Here's some preliminary data. I did a few experiments just to explore a bit here. And this is sort of what I'm seeing as making this a relevant question and to test my methodology. And then here's my proposed methodology, what it is I'm going to do to test my question. There are no results because there are no results yet. That's what is the proposal to the journal. And what the editor and the reviewers decide is your question important? And is your methodology an effective test of that question? And if it passes peer review at this stage, then the journal says, we commit to publishing your research as long as you follow through with what you said you were going to do, regardless of what the outcomes are. And then when you resubmit it after you do your research, the reviewers at the second stage, after the report is written, don't evaluate, are these outcomes exciting? Is this great new results? They evaluate, did you do what you said you were going to do? And did you interpret the results, whatever they are, responsibly? That change fundamentally changes the incentives for me as an author. Right? Instead of having to get beautiful results, I get my reward, the publication, by asking important questions and designing beautiful methodologies to test those questions. And I no longer have to try to control the thing that in science you're not supposed to control, the outcomes. The outcomes are what we learn. They're not the things that should be the basis of reward in the ideal world. So Register Reports addresses that directly. So there are about 300 journals now that offer registered reports as a submission option. And so there's a lot of questions of whether they're actually meeting the goals that I just articulated in concept. And the initial evidence suggests that they are doing so. So here is a paper by Anne Scheel and her colleagues, where they compared standard articles with a sample of registered reports that were published after the results then were added. And what you're seeing is that in the standard reports, more than 95% of the initial hypothesis in the paper was supported by the data. Everybody's right all the time. And that is standard observation whenever you look at a sample of articles in almost any subfield in science. There's a strong preponderance of positive evidence supporting the researcher's claims. With the sample of registered reports, less than half of the time were researchers' hypotheses supported by the data. That pre-commitment by the authors to say, this is my design, right? They pre-registered this with the journal in this case. This is the design, this is the question, this is how I'm going to analyze it. Their results were often not consistent with what they anticipated. And often were negative results, but they still got published. So the registered report model appears to be effectively addressing publication bias of what might otherwise get filtered out and not reported. When we share that evidence with editors, a common reaction is to say, oh, well, I think that's why I don't want to put registered reports in my journal, because if I publish registered reports, then I'll be publishing a lot of negative results. And those are boring and no one will cite them. And then my journal impact factor will decline. And while we might not like that rationale, it is nevertheless a rationale that is important in the research culture because journals also care about their prestige and reputation. And right now that's tied to journal impact factor, right? JIF. So it's at least worth looking to say, is it the case that registered reports are cited less than standard reports in the same journal? And that's what I'm showing you right here, is that in this investigation, looking at 3 different citation databases, Google Scholar, Scopus, and Web of Science, and compared registered reports with other articles published in the same journal at the same time to see which one, whether there's a difference in how likely they are to get cited. Above 100 is indicating that registered reports are cited more than standard reports in the same journal. Under the line is the opposite. So if anything here, registered reports are cited a bit more, but you would say roughly equivalent to standard reports in the same journals. So at least the initial data suggests there is not a citation decline for registered reports, even though they're producing more negative results and lack of support for hypotheses. So there's a couple of reasons that might be the case. And I think a key one is on the perception of quality of those registered reports compared to standard reports. So that's a thing that we investigated recently in a paper that just appeared a few months ago, I think, in Nature Human Behavior, where we essentially did a new peer review process to published articles that are registered reports or comparison articles, one set by the same authors on similar topics, and then another set in the same journal as the registered report on a similar topic. And then we matched peer reviewers to conduct a review of a pair of articles, one registered report and one of the two comparisons. And then they had to evaluate them on 19 different quantitative outcome criteria. And they provided qualitative feedback as well. But I'm just going to show you the quantitative criteria. And they had to do this evaluation systematically. First, they read all of the material like a registered report, the introduction, initial experiments, if there were any, and then the methodology of the final experiment. And in pink, red, whatever color that is on the top, are the outcomes measured when they've rated before they've looked at the results. And anything right of the dotted line is indicating that registered reports were evaluated more favorably than their comparison. And what you're seeing here are Bayesian credible intervals with the black dot as the effect size estimate, and then 80 and 95% credible intervals from the thicker and thinner lines. And so what you can see is that across these criteria, the rigor of the methods, the quality of the methods, how much people estimate they will learn, the quality of the research question, registered reports were evaluated more favorably than the comparison articles on average. And even on items where there's a good reason to anticipate that standard reports may actually outperform registered reports, like the creativity of the methods or the novelty of the question, even in those cases, it was either equivalent or slightly favoring the registered reports in this sample of them. Then we gave the reviewers, the results and discussion of that final experiment to evaluate. And that's in blue here. And you can see that on all of those criteria, the rigor of the analysis, whether the conclusions are justified, the quality of the results, the quality of the discussion, again, registered reports outperformed comparison articles by the same authors who are in the same journal. And then we gave them at the end, the abstract and title and all the other information, had them give a global evaluation of the paper. And you can see there, finally, in green, registered reports tended to be higher rated on average compared to comparison articles. Now, this is one study on one sample of these articles. So this is not comprehensive evidence of registered reports outperforming research of all kinds, but it's at least enough evidence to suggest that this is a model that's worth continuing to test and see how far it can be pushed. And it's part of what is more generally an effort to shift research culture and standards towards more openness and reproducibility. Right? This was an example focused on the journal and article as the publication as the key incentive. But of course, decisions about who gets hired and who gets promoted at universities are a key driver of the reward system. Funders' decisions about who gets funded, and societies setting norms and standards for how researchers should do their work are key parts that need to be adapted. And so just for time, I won't go into examples of these, but happy to discuss them more in the discussion. But I want to give a highlight to how it is that these different stakeholder groups can work together on shifting the research culture towards things that are more aligned with our values. And that is in the registered reports model. If this was unfamiliar, you're probably listening to it saying, wait, this sounds like grant proposals, because it really does, right? You are proposing the work you're going to do, and then the journal makes a commitment. So this creates this great opportunity for journals and funders to work together in trying to reinforce rigor and higher standards for research that benefit authors. So we have been cultivating groups where a model of matchmaking between journals and funders, a single review process where authors submit their planned work, and if it passes peer review, the journal commits to publishing it and they get the funding to do the project. And everybody in this cycle likes this. Authors say, I submit once and I get the publication and the money, like sign me up, that sounds great. Journals say, oh, I get high quality research at our journal that's funded, great, we're on board. And funders say, hey, you mean almost all of the work that we fund will eventually get published? so much of the work we fund never gets shared at all, right? It's lost forever. We get no return on that investment. This sounds good. So in addition to reducing publication bias, creating more planning, potentially reducing waste, this process engages everybody in ways that are aligned with their own interests and in line with the values that the research community is trying to promote. So we actually have funding from the National Science Foundation in the US to evaluate whether these types of interventions are effective in shifting culture change. So the funders listed in the box there have all made commitments to conduct interventions like this in research communities that they operate and fund so that we can evaluate their effectiveness. So there's a great culture, not just us, many of trying interventions to shift the culture and simultaneously evaluating their effectiveness, identifying where they work and where they don't work so that we can continue to improve. So let me conclude by just returning back to this dysfunctional culture. And I gave a few examples of things that if we could change those would have a particular impact on the research culture. So for example, if data and materials were shared by default when they can be shared, right? Not sensitive information, not commercial competitive information, but data that can be anonymized and shared more freely, then that can address one of those dysfunctional behaviors that produce bad outcomes. Right? Pre-registration can address selective reporting and questionable research practices by getting pre-commitment to what's planned and making very clear in subsequent reporting what's unplanned. And registered reports goes after that initial incentive itself and is an example of not changing the incentive for publication, but changing what it takes, what's required to get that publication in a way that's more consistent with what we would idealize science to operate. And so as a consequence of adoption of those things, we may reduce the dis part of function and then ultimately accelerate science while also making it more aligned with the values that we have for how science should operate. Now, that's a lot of in theory, because we don't know if all of these things will have the consequences that we imagine. And so that's why we need a robust research culture about the scientific process itself to evaluate whether these behaviors and changes that occur have the intended consequences, and that we are attentive to any unintended consequences that take us away from what we would idealize that what these would produce. So all of that fits into a broader effort to adapt the research culture toward greater rigor and transparency. And from our point of view, there is a interdependency between key things that make it possible to gain adoption in the research culture. At the base is you have to make the behaviors that you want to produce possible and ideally make them easy. If we don't integrate open data or pre-registration into researchers' workflows, then it's going to be very hard to adopt because researchers are busy. And trying to engage new behaviors by adding them on to an already busy schedule is not a good way to get new behaviors. They have to be integrated into how it is we do our work every day. At the top, making things rewarding and making them required through incentives and policies is the way that stakeholder groups like universities and publishers and funders can shape the behavior that is done in the communities that they serve. But the key for all of that is in the middle. And that is what groups like the Italian Reproducibility Network are doing, which is building community engagement, shifting norms in the way that norms in science work. Top-down does not go very far in a very decentralized system, right? Because one journal might adopt that behavior, but another journal might not. So you have to have a very robust community that is developing new norms, providing training, evaluating the effectiveness of these, taking something like pre-registration, saying, well, I can see how that would work in an experimental context, but how would it work for longitudinal data? Or does it even apply to qualitative research? Or if we do that, do we disadvantage exploratory research in some way by promoting this new behavior? Those are critical questions that the community has to wrestle with and find solutions for to figure out what are the best processes for the way in which our research works. And so that normative element is critical for policies that get enacted to be enacted well, and for making the best use of the technologies at the base to help promote their adoption and effective adoption overall. So let me end now just by pointing out that the culture is changing. I opened with that sort of dispiriting slide of our collective sense, if our personal experiences resonate with what that sample showed, of my values are here and I don't see them being represented in the culture. But there are things changing in the behaviors like data sharing, being more transparent, producing a culture that values self-skepticism. And I'll just provide a couple of examples from our own work. So one of the things that we do at the Center for Open Science is maintain the open source software called the Open Science Framework. And this is an infrastructure that helps support doing these behaviors that I mentioned. And so I'll just, because I have easy access to those data, I'll just show you that the adoption rates of that. It was first created in 2012, the infrastructure. We formed the organization in 2013. And this is just showing you the number of registered users that are using the OSF to share data or preprints or pre-register their research. This is through 2020. In probably a week or two, we will cross 400,000 users of the OSF. So before the end of 2021. So it's continuing that nonlinear increase. Just using the OSF for registering studies, you can see similar nonlinear growth in that, and that is crossed, I think it's already crossed 80,000 something in 2021. And then it's not just people using the OSF for their own work, but there's also consumption of the work that people are people are sharing. So just in 2020, the users posted 3.27 million files, data sets, materials, methods, protocols, and made a substantial portion of those, 2 million of them, publicly available. Right? You can use the OSF privately for those things you can't share, or for managing your project until you're ready to share. So you have an option of both private and public. And those files were downloaded 36 million or more times, suggesting that they are providing some value, at least attention, for others in the research community. And then you can see the growth in the number of visitors to the OSF that are observing or downloading content over time. So I want to end there so that we have some time for questions and discussion. But I want to point out again that there's a link at the base here. Take a picture of your screen if you would like to get these slides. And then if you want to follow up on any of the information of things that I mentioned, we have support pages for each of these, and all of the stuff is freely available. Also in these slides, there are references to some of the research that I mentioned and other things that are relevant. So I will stop there. Thank you very much for your time and attention. And I will also stop sharing my screen so that we can have some conversation.
Thank you a lot, Brian. I think it has been really been a really exciting and informative presentation, and also because I like the fact that it shows that open science. Sometimes people say open science can makes research more difficult, especially for the young people, but there are some things that in fact make it easier, like the initiative that unifies the presentation of the grant, of the grants and the register report is really something that makes science research easier. So it's not true that doing open science is a kind of a burden. It can be really the opposite. So I really loved this aspect, and yeah, I don't know if there are questions. I don't know. I put the indications to ask questions in the chat. So if you want to ask, please just let us know. Okay.
While you're looking at that, just to respond to your point about making things easier and perceptions that open science can be difficult, I think that's a very important point. And of course, we don't comprehensively know how much some behaviors are harder and easier, right? It is more work to share a data set than to not share a data set, inevitably. But there's ways to do a lot of these things efficiently. And there is a learning curve. So in my lab, we started pre-registration in 2011, and it was hard at first because we didn't know what we were doing. And it took some practice over a few different, over years to get better and better at it. To the point now where it's almost impossible for me to think that we wouldn't pre-register, because the role that it plays for us is to help our planning. And it makes us much more efficient in our research process. So just giving a concrete example, it happened too often where we would run a study before we would do pre-registration, where at the end of the study, we realized, oh, we can't really analyze the data to test the question we wanted. Or, oh, we forgot to do X, Y, and Z of something that was important for our hypothesis. And so it was a huge amount of waste. But with pre-registration, and now there are a lot of templates that we and others have created to help guide one through the planning process for that research, so that you know precisely what your plans are, and you can catch those errors before they happen. So I think overall, even though it took us some more work to move this up front, it has made us much more efficient in our research process. Every study we do is informative and useful, rather than introducing waste that we could have avoided if we had planned a bit better. So thanks for raising that issue, Christina.
Thank you. Now there is, there are some questions. First, let's see. Etzer, can you give the...
Yes, the first question is from Evelyn.
Are you okay in appearing in video, Evelyn?
Yeah, I'm fine with it. I thought that would be easier to actually ask question like with the voice rather than like typing. Oh, I just have like kind of a two question. First of all, thank you for your talk. I didn't know about this register report and stuff, and it sounds really good initiative, or I mean it's actually going on. But and so my first question would be, how is it like writing a paper using the OSF data and publish that paper in a major journals, and are they having like more acceptable that like we're using these open data sources rather than our own data, or using this like European Social Survey data? And my second question will be it's more about like, it's really nice that it kind of helps us kind of focus on the research itself rather than like trying to find like a good looking results. But what I noticed sometimes is that there are also kind of a cultural like differences in like between the major journals in United States or in like Europe. Even within Europe, there's a different focus on what kind of evidence they like, or they're more oriented toward experimental or more like theoretical. I think there's a bit of a different gear. So even though we have this peer review before actually running the study, I don't know whether it can also still, like, in what ways this pre-register help in a way to tackle this, the culture of journal that wants certain kind of study in general. So even though you submit it before you actually conduct the study, what if they don't like my study because that's not the type of the research they like? Yeah, so that's
okay.
my good view.
Great, excellent questions, Evelyn. So on the first one, on open data and valuing reusing other data for publication, this is something that varies a lot across disciplines, where in some fields, people don't collect any of their own data. They only use data sources that are made available by others. And so it's very normal to do so. Whereas other subfields, like what? You would use somebody else's data? Ew, like, get your own. And so there is some variation that is emerging where people are recognizing in those fields where it's less common, oh, there may actually be some interesting potential uses for open data. The things to pay careful attention to are when you're reusing data is obviously citing the source and attending to what other uses of that data have been made already. because one of the big negatives would be, are you just doing the same thing that somebody else has already done with the same data? Many data sets that are shared have broader application than what the particular purpose was for initial sharing. And so it's often easy to make the case for unique uses of data, especially if you can find multiple data sources on the question that you're investigating and aggregate them to create a higher powered or more effective test of whatever the question is that you're asking. So there is a lot of change happening in appreciation of reuse of data as a scholarly contribution across fields. So that's a great thought. The second question on the applicability of registered reports and how it interacts with journal priorities is an important one. Journals have their own character and priorities, and that's going to happen, and diversity there is probably a good thing, right? As you see that, oh, there are different kinds of ways that I can make contributions, and journals try to fill a niche for what it is that they reinforce and support. It is not clear yet that registered reports will be a useful complement to the standard model for all kinds of research applications, right? So an example of what you just said, of a pure theory paper, it's not obvious why you need a registered report, right? You write, I'm going to write out a great theory. No, that's not how, no, create your great theory. And if it's a great theory, we will be happy to publish it. So you can't really know if your theoretical paper is going to be good until it's done. And then we do also still need a rich culture of exploratory research. The challenge we have in the current culture is that we're incentivized to dress up exploratory research as if it was planned, or as if we already understand it all. And so we convert to our own a threat to ourselves what is really exploratory work, discovery, accidental, stumbling into this, into these narratives that tell a good story for why it occurred that way. And what I think registered reports and pre-registration offers for that is to embrace the value of exploratory and represent it clearly as exploratory. So even in the registered reports model, you have all your plans. This is what we said we were going to do. This is how we said we were going to analyze our data. We report it that way. But then after that, in a separate section, you can do any and all exploratory analysis of that data you want. And that's a good thing, right? It really helps the reader to say, oh, okay, you had those plans, didn't come out that way, or maybe it did. And then here are all the other things you looked at to try to understand that data from different perspectives, or why it is you might not have found what you found. As long as it's clearly demarked as exploration, then the reader can calibrate their confidence in those findings. That drifted a little bit away from what your initial point was, but it just is to illustrate that there is diversity in what kinds of research are valued. That in general is a good thing. And we have no one size fits all solution that's going to address those challenges. And so we have to be attentive to adapting to the research context that we're in. So thanks for those questions.
Then there is a question from Rosandra. She asks, if I pre-register my study, upload all data and materials on OSF, but I use the embargoed mode, or I make it all public only on request, is it still considered an open science approach?
Great question. So for those that are less familiar with OSF, you can have it in private mode or public mode for your data. If you just want to share among collaborators, you can leave it totally private. You can also have a middle mode of request access. So if people get permission, right? Maybe I have sensitive data that I can share if you have appropriate ethical approvals, but I have to keep it private because it's health data. So you have levels of control of how accessible it is to the public. But there's also a feature in pre-registration that Rosandra mentions of embargoing, where I pre-register my study, but I don't really want you to know about my study yet for whatever reason. You can embargo it for 4 years. So it will become public eventually, but it's not going to become public right away. And that's helpful for some people that are worried about potential exposure of early to participants or for competitors in their environment, whatever reason. It's like, fine, if you want to embargo, you can embargo. So Rosandra's question is about what really counts as open science? Do you have to make it all open all the time? Or what about these more middle ground areas? I think my answer would be that we don't want to invoke purity in terms of what is good research, right? It can't be the case that everything being all open is the only kind of research that we'll respect. And anything that closes access to some or more of it is therefore not good research or ideal practice. Because what that would do is rule out a lot of research from being considered credible work, because it cannot be open for very good reasons, right? So that you might work with a very sensitive population that's marginalized and at risk of attack from the community or for political interests or otherwise. It may be very difficult to anonymize data from that group sufficiently so that they wouldn't be at risk. And so even the most rigorous, most outstanding work in that field may have to be protected, still closed to some degree, and not fully open. And we need to embrace those scenarios as totally reasonable situations that the community and practices need to be responsive to. Simultaneously, we can say that we aspire to be as open as possible, but no more open than we can be to meet our ethical, legal, and other kinds of requirements. So that's my sort of general answer is, of course, we want to make open the default, that's the assumption. You start with the idea of, oh, I'm going to make my things available, but then you make decisions about what can be made available based on these other practices or other considerations. So thanks very much for that question, Rosander.
Then there is Luca, who is asking if there is any filter to find out pre-registered work in common search engines like Scopus, etc. Not
yet. That is a great idea. The metadata that supports search engines doesn't yet have much indication of pre-registration, but there is work going on by the service providers. We're part of a community of these networks of infrastructures that maintain all of this stuff for search and discovery and everything else. And a number of the key players that are involved in metadata for search are starting to incorporate fields for pre-registration. And then what we're also trying to do is get journals to make standard practice, putting metadata of whether data is pre-registered, whether data is shared, whether the study was pre-registered, whether materials are available, things like that, so that there is rapid transfer of information between journals and those articles and search engines, so that it would facilitate discovery like the question you asked. For now, you have to go to search and registry by registry to search for pre-registered research. And it doesn't always make it easy to know if this pre-registered study, which publication is it connected to. So there's still a lot of work to do in making those things more connected and more discoverable.
Then there is Valentina asking if you can point us to available guidelines or training on how to write a good register report.
Yes, there's lots of material on this. And I'll just put the link that it was on that last slide into the chat, cos.io/rr. That's a place to go to get started on discovering information about registered reports. There's links to examples, there's links to guides, there's links to webinars. So there's lots of information out there, and that's a good place to start. If you can't find what you need going there, then just email me and I will connect you with people that can help.
One second, I lost the questions. Okay, Maria is asking, register reports are going strong in psychology and a few other related fields. Do you have any indication on that they are being adopted also in other scientifics or in other domains?
Yeah, great question. Yeah, they emerged most strongly in psychology and human side of neuroscience. but they are growing across fields. So at that link, you can now see what journals have officially adopted registered reports as an option for submissions to their journals. And there are journals that publish across all fields that are adopters of registered reports. I think Nature Communications is one, and PLOS One is another. And there's rapidly increasing adoption across different research fields. When you look at the list, most of them are still in the social behavioral sciences. Psychology is well represented, but increasing representation, political science or education research or other domains related. But there is growing adoption in the life sciences, and where it is slowest is in natural sciences. So there aren't many, except for the generalist journals. Royal Society Open Science is another generalist journal. There aren't many that are doing it in chemistry or physics or other fields yet, but I'm interested to see if there's some initial adoption and evaluation of the value of that model in those subdisciplines.
Okay, I don't know if you have time for another question, a last question by Valentina. She asks, do you see any relation between register reports and that data management plans? Could data management plans be considered as an important piece of a register report?
Yeah, great question, Valentina. Yes, and the more general concept of a pre-registration has a lot of parallels with a data management plan. So both of them are, what do you plan to do before the work is done, right? Those initial sort of aspirations. Okay, this is what the experimental work, the design is all about, the analysis plan and the pre-registration. Data management plans are, what am I going to do with the outputs? Once I've produced all of this work, am I going to share it? Am I going to have it be protected access? Am I just going to get rid of it? Right? What's going to happen? Both of those are key parts of the planning process, and journals that are progressive on registered reports tend to also be progressive on adopting policies to promote data and material sharing. We maintain what's called the TOP guidelines, which is a policy framework for journals or funders or institutions to decide what their transparency standards are. Journals adopting registered reports tend to adopt pretty assertive standards on the top guidelines as well for data sharing. So in that regard, Valentina's question is very valid, which is you kind of would need to say, here's how I'm going to manage my data for the journal to be able to evaluate whether it meets the standards and policies there. But a more general answer is even that a lot of funders have already made progress on data management plans as something that they require, and they don't yet have strong stances on pre-registration or even registered reports. But they're interested in potentially having these two things be joined in some meaningful way to improve reporting back to the funders so that you can register your data management plan and your experimental and study designs, and then have those be automatically reported to the funders so that they can see that you're meeting whatever requirements they have. So that's on our technical roadmap, is trying to facilitate some of those reporting standards through the OSF. And I imagine that other services like OSF are doing similar things.
Okay. Thank you very much, Brian. It seems like there is no other question. I think that we have also been gone a little bit out of the time that we planned. So really, thank you very much for being here, for the patience that you have had with us at the beginning. And yeah, thank you all for being here, to all the participants. And I hope to see you all in a few weeks for the second meeting of our series of seminars. And yeah, that's it. Thank you again.
Right. Thank you, everybody. It's delightful to be here. I appreciate all the discussion.
Okay.